The transformer models have only been around since 2017 or so, but they've completely changed the field of natural language processing. And the key idea is this attention mechanism. It was introduced in 2014, but used along with RNNs. Soon they discovered that without the RNN, with just attention alone, they could handle entire sequences all at once. So now all these long-term dependencies between words that weren't such a problem anymore, and things could also be run in parallel. That made training more data with bigger models much faster. And of course, that led to these pre-trained large language models. But it could take millions of dollars to train a model. So most people start with one of these pre-trained models, then fine-tune them for a specific downstream task like classification, text generation, or whatever. But these language models are actually already quite impressive that sometimes they don't really need a whole lot of fine tuning. Things might work after just one or a few examples. And sometimes they could even work right out of the box for whatever you want to do with zero examples. So that's what the term few shot, one shot, and zero shot learning refers to. Now, there's tons of transformers out there, but they roughly fall into three types. In the original paper, transformers had both an encoder, see on the left, and decoder on the right. And these generally take a sequence of input, but also generate a sequence for the output. So they tend to be good for tasks like machine translation, text summarization, and question answering, tasks that take a sequence for both the input and the output. And examples for an encoder-decoder transformers would be T5 and BART. Just be careful, BART here is different from BERT, which we'll talk about next. So transformers can have just the encoder only. And so these generally take a sequence for an input and then encode it into some simpler output. So they tend to be good for tasks like sentiment analysis, classification. The most famous of the encoder only transformers would be BERT, which stands for bidirectional encoder representation for transformers. And Roberta is the exact same architecture as BERT, but it's just been trained longer. It's robust BERT. And BERT's actually been tweaked and optimized a zillion ways. So there's actually a bunch of BERT-based variants out there. And you might actually also hear the term masked or closed language modeling. And it just means that BERTs learn the language by doing these fill in the blank tasks. During training, a few input tokens would be randomly masked, and it's bidirectional because it can use information from both to the left and to the right when it's learning to predict the masked token. Then transformers can also have just the decoder only. And these generally take a prompt as an input, then generate a sequence as an output. So they tend to be really amazing at generating all sorts of these human sounding text. And the most famous example would be the whole family of GPT, including the now GPT-3. GPT stands for Generative Pre-trained Transformer. And these have generated news articles, poetry, stories, and much more. The output can be so impressive that it's sometimes hard to tell if it's written by humans and what's not. And you can even give GPT-3 instructions in plain English, and it'll generate computer code like Python or JavaScript. And with these, you might also hear the term causal or autoregressive language modeling. And it means that GPT can only look at the tokens that came before the current one. So unlike BERT, it's unidirectional because it can only look to the left. Since it's learning to generate the output, it'd be cheating if it looks ahead to the right. So we've been talking about large language models. So how large is large? Well, Here's a linear graph from 2018 to 2020, and it shows the number of parameters in the millions. So Elmo was the largest LSTM before transformers. It had 94 million parameters. The first GPT, the decoder only transformer, had 110 million, and that's only a little bit bigger than Elmo. Then BERT, the encoder only transformer, was double that at 340. Then from GPT-1 to GPT-2, they went from 110 to 1500. That's a tenfold increase. And T5 is an encoder decoder transformer, also from Google. So with 110 billion parameters, that's 10 times larger than GPT-2. And here's a similar graph, but the vertical axis is now logarithmic. And so you can really see the exponential growth. From GPT-1 to GPT-2, we saw a tenfold increase. Then from GPT-2 to GPT-3, there's a tenfold, a hundredfold increase. And according to reports, GPT-3 to GPT-4 should be another hundredfold increase. So there's this clear trend with more parameters, more data, and longer training. So companies are investing millions of dollars training these large language models. But maybe you don't have $1 million to spare? Well, luckily, with the Hugging Face Transformers library, you too can play with some of these large language models. So next time we'll see how to do that. And just to let you know, much of the information here was pulled from the Hugging Face website. So I'll link it to the description and feel free to explore on your own, okay? See you later.